I'm adding this sixth video to the basics section, and you'll find the corresponding core concept 6 as well, because I want to talk about equilibrium and the free body diagram. I really want you to be able to understand this and intuitively grasp what's going on and how to look at a balance of forces, or how you analyze mathematically the forces that apply on an object, right? So that's really the idea here. I'm going to start off with an example, right? I'm going to take my all-time favorite box of coffee capsules. So here I am holding this, and think about what happens, right? This has a certain mass, and acceleration due to gravity typically will cause it to feel some weight, which is now acting down on my hand. And if I obviously stretch my hand out, it's not very heavy, but eventually my arm will feel sore. And that's because there's a certain force that I'm applying constantly to keep it there, right? And what I want to do is have you analyze. Imagine my hand wasn't there, and what would be the state of this box? And that's really what I want to bring forth here, right? So what I'm going to do here is I'm just going to draw the box, right? And there is nothing else that I'm going to draw, right? But for the purpose of the example, imagine what's going on there. Now, let's take a look at what's going on. The box doesn't move. It's not falling down, right? It stays there. So there is a force, and you could put it this way. There is a force that's naturally acting down, and I'm going to do this, right? Just assuming that there's a center of the box, right? So there's a force acting downwards, and Newton's third law means an equal and opposite force exists as well. So that's the reactive force, right? So what happens is these two, and let's just name it, and we'll call this just force, and we'll call it force of box, right? In reality, it's basically the mass of that box times acceleration due to gravity, right? Which results in the weight. And this, we can call it, let's just say, reactive, right? I'm just calling it reactive, and they have to be equal. And when they are equal, what happens? The body just stays as it is. There is no change in its state of motion. The net effect of all forces is zero. If it had to move, there'd have to be an external agent. Either I would have to let go of my arm, which means the force with which I'm holding it goes down, or the force I'm applying back on it goes down and then the box falls, or I have to apply a greater amount of force to lift it up. So think of it this way, right? And the reason I put it this way is this is the way you would kind of start working on problems in physics and mathematics as relates to mechanics. I also want to give you one more example, right? So I have here with me a whole bunch of keys. This is fairly heavy, and I want to just illustrate this to you. I'll take this away, and you can see this. It's hanging on a string. So what's going on here? Let's just say my bunch of keys, and I'm going to just illustrate this with a circle, right? It's a bunch of keys. This is going to exert a force downwards, right? This is the weight of the keys, right? So again, this is force, I'm just going to say, of the keys, and that's equal to their mass times acceleration due to gravity, right? Which is typically the weight now of the keys. Now what's going on? The string is applying, and that's why the string is fairly, you would call it tense, right? It's not, there's no slack. The rest of the string is really soft, but this is not an elastic string, so it's holding it back. That means the string is now applying an equal and opposite force, and that's the reactive force. That's Fr. And for this bunch of keys to stay in this position, these two forces are equal and they're canceling each other out. If the string wasn't there, if I cut it off, it would just fall, right? And that's really the idea I want to leave you with. And this representation is typically called a free body diagram, right? And I want you to start thinking about this, because you'll see this, and this is sort of how we will solve problems as you go into the core concepts and further, when you have to analyze what's going on with several forces acting on a particular object, right? So I'll leave you with this. Just wanted to bring this in here in the basics level so you start understanding how the mathematics will be developed in an object. We treat that object by itself. We don't have to indicate a string, or here we don't have to draw a floor or anything like that. We get the concept in your head saying that, okay, this is how an object is, and these are the forces that play on it. And free body, because there's nothing else that's touching it. We're just representing the forces that act on it. So I'll have more of this in Core Concept 6, but thought I'd just add this in. Thanks for watching.